Hi, mathletes. Talking today about linear function pattern recognition. Our objectives are to identify linear functions given a table. In particular, today we're talking about x values when they change by different values. We're also going to talk about rate of change for linear functions from a table, focusing on the unit rate when you're given a change of x that's other than 1. Our opener today is that another cell phone contract, and you are given an initial fee of $300. And again, you're going to see that in the table at 0 months. That would be your initial fee because that's your starting fee. And then your monthly payment for unlimited voice, text, and data is unknown per month, question mark per month. That's what we're trying to find. We want to know that that's the first question being asked right here. So it says, using the table, what is the monthly payment? So if we look here at our table, and again, we are calling this a month and the amount spent, but this is still just like an XY table. And so we're going to do the change in X and the change in Y just like we would if there was no context attached. And so if we look here, I want you to take a minute to just find those differences for X and for Y. Hopefully your table matches mine. You can see here that our change in X, which is the change in month, is 2 months. And our change in Y, which is the total amount spent, is $90. And we're looking for how much have you paid each month. Each month means 1 per month. And right now, we know something about how much we spend in 2 months. So let's write that out. So you can see that we have $90 per 2 months right there. And this can be reduced to our unit rate by dividing. 2 goes into 90 45 times. So it is $45 per 1 month. And how do we know that? We could say we reduced our rate of change to the unit rate, because then it's per 1 month. Next it says, which of our 4 functions do you think this is, and why? Well, if I'm looking at my table right here, what is this telling us? Hopefully that's telling us that we have a constant rate of change. And if we have a constant rate of change, we know this is a linear function. Just a quick remark about this table from our opener. You can imagine, now you don't have this on your paper, there's nothing to write down, but you can imagine that this original table that's given to you could be expanded so that we add in what happens at 1 month, what happens at 3 months, so we can figure out what happens between these months when we go by 2s. And you can see that the rate of change over here is 90 over 2. The rate of change for the more expanded table is 45 over 1. Those are equivalent. That's exactly what we got on the previous slide. So we're looking at our whole practice now. And for each table represented below, you want to identify the rate of change, including the unit rate, and identify the type of function represented. So this is going to be just like you did in the last lesson, except for your x values are not going to go by 1. So you're going to find the change in x and the change in y for each one of these tables. So looking at our first problem, what is the change in x? And you're just going to calculate that. 2 plus 2 is 4. Remember, you can use this number line. So you're starting at 2 and you're going to 4. So that's an increase of 2. That's where that's coming from. When you are looking at this, you can't always see it on the number line that's shown here, but you can imagine. So 16 would be right here, and obviously 26 would be further to the right, so you know you're also increasing, and hopefully you see that that's an increase by 10. What I'd like you to do now is show me the rest of those changes for each part on your table. So you can see here that we have change in y are all plus 10. The change in y are all increasing by 2. So what does that tell us about a rate of change? So if you'll recall that a rate of change is always the change in y over the change in x. Well, if our y values are all the same and our x values are all the same, then our rate of change is going to be the same, which tells us that this is a constant rate of change. So you start here by saying constant because it means the whole table has the same rates of change or equivalent rates of change. And then we're just going to write that fraction. So our change in y is increasing by 10 or positive 10. Our change in x is 2. We can reduce that. Remember, a unit rate means that it is something over 1. So in this case, this fraction can be reduced to 5 over 1. How can it reduce to 5 over 1? Well, it's because 10 divided by 2 is 5 and 2 divided by 2 is 1. So that can be reduced, and our unit rate is then 5 over 1. Make that look okay. And then if we have a constant rate of change, then we know our function is linear. So what I want you to do right now is to do your change in x and change in y for example 2. Hopefully you see here that you got the same change in x. -2 going to +1 is an increase of 3. It was the same increase of 3 all the way down for their x's. For the y's, we are decreasing by 9. So from 14 going back to 5 is decreasing by 9. And so because our change in x's and change in y's are exactly the same, that again tells us that this is a constant rate of change. And our change in y is -9, and our change in x is 3. These do divide nicely so that we can reduce this fraction to -3 or -3 over 1. And that is also our unit rate because our unit rate is always per 1. And what that tells us is that when the x increases by 1, the y decreases by 3. So if the x, just like over here, if the x increases by 3, the y is decreasing by 9. If the x increases by 1, the y is going to decrease by 3. That's what that's telling us. And of course, because this is constant, we know this is a linear function. And now I want you for the next one to do the same thing. I want you to find the change in x and the change in y. So you're going to go through and do that for the whole table. So looking at our table, you can see that the x values, the change in x, the x values all increased by 5 along the whole table. So -8 plus 5 is -3, -3 plus 5 is 2, and so on. These all increased by +5. However, the y values, this is why you need to be careful, they didn't all change by the same amount. I changed by 25, increase of 25, 16 plus 24 though is 40. 40 plus 26 is 66. 66 plus 25 is 91. So these came out to different values. So this is not constant, and that means that this is a non-example. So this is not constant, so this is not a linear function, so it's a non-example. You can still write rate of change, except for there's not one rate of change. We have for a rate of change 25 over 5. We also have 26 over 5, and we have 24 over 5. So we have 3 different rates of change. And if we want to write those as a unit rate, we'll have to divide those. So when the unit rate is something like 25 over 5, that's pretty simple because 25 divided by 5 is 5, and so that goes in there nicely. However, 5 does not divide evenly into 26. It goes in there more times, and that actually, if you divide that in your calculator, 26 divided by 5, you get 5.2. And when you divide 24 by 5, you get 4.8. So you can still write those. We have 3 rates of change for this particular table with 3 units rates. So we'll just draw an arrow there since I'm not going to squeeze them into my line.